Hi everybody and welcome to DPS 2022. I am Shreya Aithal. I'm a program manager in the Azure database for MySQL and MariaDB team at Microsoft, and I've been an active member of Data Platform Geeks as well for over 4 to 5 years now. I'm super excited to be talking to you about how to develop and deploy MySQL applications on Azure App Service. Essentially, the integration of Azure App Service with the fully managed MySQL service on Azure, that is Azure Database for MySQL Flexible Server. So before we jump into how to develop and deploy these applications, I'd love to just cover briefly what is Azure Database for MySQL, especially for those who are new to it. Azure Database for MySQL Flexible Server is a fully managed MySQL service on Azure, right? So it brings the goodness of your favorite community database, that is MySQL, and integrates it with the power of Azure. That is in terms of scalability, security, reliability, and performance as well. And one more important piece is the power of the Azure ecosystem, the ability to integrate with all of these other services that is present in the Azure ecosystem itself. Now, our customers use Azure Database for MySQL Flexible Server for a number of things. That is, web apps using content management systems like WordPress and Drupal, or e-commerce applications like using Magento, or gaming platforms, or mission-critical line of business applications, or even cloud-native applications, the applications that are born in the cloud and using Azure Kubernetes Service, container apps, etc. But the underlying theme is any web scale application that needs to be scalable, performant, and portable. That is where MySQL and Azure Database for MySQL fits in perfectly. Now, to develop with MySQL Flexible Server, you can use your favorite tools and frameworks. Any of the tools and languages that you are familiar with. It could be open source tools like Command Line, Workbench, or third-party tools like HeidiSQL, or even Visual Studio Code or GitHub, or even languages, any of the languages that you absolutely love coding in, right? You can continue to use them. And you don't have to learn anything new just to fit into the MySQL Flexible Server framework. And in terms of integrating with the Azure ecosystem, you can integrate Azure Database for MySQL with any of the Azure Compute services like App Service, Container Apps, Azure Kubernetes Service, or VMs, or even Spring Cloud. And you can also integrate with DevOps like Azure DevOps or GitHub, and even other services like ADF or Synapse Analytics. Now, in this session, we are going to focus primarily on the app service and Azure Database for MySQL integration. We are going to cover a spectrum of things all the way from beginner level, that is WordPress on app service, integrating with MySQL Flexible Server. We'll set that up in minutes. Then we are going to look at web app and database integration and deploying a sample application, a Laravel application, onto Azure App Service and MySQL. And then finally, we are going to go to the advanced stage where we're going to look at what are the best practices for app development, especially if you're developing in an enterprise organization. So shall we get started? So we'll start off with WordPress on app service and integrating with MySQL Flexible Server. WordPress is actually one of the most popular platforms that is used for web development. In fact, almost 43% of all the websites are WordPress websites. And in terms of blogs, 97% of the blogs are all WordPress. Now, if you are someone who is not technical and you just want to get a blog up and running, a blog site up and running in seconds, then you will have to, set up WordPress, install it on a server, host it, integrate with a database, manage that database. Now, this is a lot of tasks for someone who is absolutely non-technical. Now, even if you are from an enterprise organization, you'd want to focus on developing the application itself and not all this infrastructure tasks and management tasks, right? So that is where I think WordPress on app service is one of the best things that you can actually use. I'm going to do a quick demo of this WordPress experience and we'll see how you can actually get everything up and running in seconds. So go to the Azure portal and search for WordPress and click on create. Now you will see that there's very little information that you actually need to give to get all of this up and running. First, let's create a new resource group, maybe something like RGDPS, right? And we will choose a web app name, right? So it is WordPress DPS. And then we can choose between different hosting plans, either choose basic or standard or premium. Let's just choose standard for now for the demo purposes, and then put in your admin username, which you will be familiar and comfortable with. This is to sign into WordPress itself, and then put your password. And that's it. That's all you need to feed in, and then just click on create. Now for the purposes of this demo, I've already created a WordPress application. Go to the overview section, click on the URL, and you will be able to launch your WordPress application in seconds. And if you want to build it, just go to WP admin, type your username. I think mine was demo user, and I'll type in my password as well, and then login. And there you have it. You can go ahead and develop your WordPress application from right here. Now, if you want to manage your MySQL database server itself, that is also possible because phpMyAdmin extension is default installed for you. All you have to do is put your username and password for the MySQL database and hit login. And you can manage the MySQL database from right here. So that ends the WordPress section. The next thing that I want to talk to you about is the web app plus database experience. Now, if you are going to develop and deploy your custom application on Azure App Service and integrate with MySQL Flexible Server, what you would have to do is create an app service plan, then create Azure Web App, then you create Azure Database for MySQL, then connect these two together. And then you're also thinking about how secure is this connection? Should we put them all together in a VNet? There are so many things to think about and actually get to a point where you can deploy your application, right? To simplify all of this and to make the experience secure as well, we have web app plus database. Let me show a demo of this right away. So go to the Azure portal, search for web app plus database and click on create. So just like you saw in the WordPress experience, there are very little things that you need to fill in to get this up and running. Just give the resource group name, put your web app name. Let's choose app DPS this time, and select a runtime stack. So for example, because in the next demo we are going to use PHP 8.0, a Laravel app, let's choose 8.0, and actually the recommended engine is already populated for you. A server name is created, a database is created as well. And you can also again choose between basic and standard, and then probably just go ahead and review and create. There's nothing else required to get your web app, MySQL, up and running and connected to each other. So once the validation is done, just hit create. Again, I've already created a web app plus database for the purposes of this demo. So you can see a web app, a MySQL server is already created for you, and it is integrated in a VNet. Now the app service, if you go to the application settings, you will see the settings in the configuration strings. You can either copy them, save them, or just continue to use them as is. Then you will also see the MySQL server that is also created for you, and everything is up and running. Now we are going to see a demo or a tutorial of how to deploy an application on top of this web app plus database that you have just created. In this session, we are going to deploy a sample Laravel application. And let me show you how, again, very simplified it is. And we're going to be using GitHub Actions in the backend just for the CI/CD pipeline, and just to show you how well it integrates with all of this. So the first thing that we have to do is create a web app and a database. Now, while we have already seen this in the section below, let's still do a quick recap. Just create a new resource group here, and the only details that you would need to fill other than this is the web app name, maybe app, because this is a Laravel task application. Let's give it an appropriate name and choose PHP 8.0. And flexible server is recommended automatically for you. Now make a note of this database name because you will need to use this later. In terms of hosting plans, you can choose standard for now and just click on review plus create. And once you review it, you can see that the app and the database will be created in a VNet, and all the details are provided here. So just click on create. So these database username and password values you can actually retrieve later on in the configuration section of app settings. So for now, let's just create the deployment. So the deployment is submitted, and it will take a couple of minutes to actually provision all the resources, because it's an app, it's a database, and also VNet resources that need to be created. Once that is created, let's actually go to the resource group itself and take a look at all the resources within it. An app, MySQL Flexible Server, and the VNet resources are all here for you. Now, actually, let's first navigate to the application, app DPS Laravel. And here comes the second step, to review and edit the connection between the database and the app service. So go to the configuration section and you will see that when you create a web app plus database, the connection is already created through a connection string, right? You can have a quick look of this at this. But the thing is, with Laravel application, you need to, the code actually requires you to have them in specific variables. So you have to create application settings and put the variables like this. DB database, put on the database value that you saw earlier and save. And the same way you will have to do this for each of the other settings, like database host name, username, password, etc., that you'll copy from the connection strings. So a couple of other things that you need to fill in is the app debug variable. This is the Laravel application debugging variable. Set it to true. App key, you actually need to generate this with an artisan key generate, but here we'll just use a default value. Then database name, then the host name, that is app DPS Laravel database, password, username, and then finally also you need to put in the SSL certificate value. The certificate is bundled with the repository itself, so you don't need to worry about downloading it and saving it, etc. So just click on save, saving this configuration. And once this configuration is saved, we'll move on to the next step, which is actually deploying the code itself onto app service. The application is actually present in Azure Samples Laravel tasks. Just click on fork and create a fork in your organization. So choose your organization, repository name, and create a fork. Now, once this fork is created, just click on the full stop button on your keyboard to open up the Visual Studio Code editor, the browser editor here. So just click on the full stop and you will see that the web editor is open for you. You can see the entire application, browse it just as you would in Visual Studio Code on your server. So you can see all the variables, the MySQL variables that you just set in app service, they're all being used underneath by the application. So this is why you had to do that extra step. Otherwise, essentially you would have just used the connection string, right? Your application could probably just read the connection string and go on. Now, the next step is to actually go ahead and create a deployment. Go to Deployment Center. Here in the settings, choose the deployment source as GitHub. So this essentially uses GitHub Actions. So choose the organization underneath in GitHub and choose the repository. Select the branch as main. And that's it. Just click on save. And a deployment is essentially created for you. A build and deployment pipeline is created for you. So once this deployment is set up, you can just go to the logs section and you'll see the deployment pipeline here. Just click on the link and it will take you to GitHub. So you can see that the build and deployment pipelines are working. You can click on either of these to see what are the actions that are actually going on underneath. So for example, the build tasks that are going on. Now, all of this will take a couple of minutes to run. Go back to the summary tab and monitor the build and deploy pipeline. Once this pipeline tasks are completed, you're actually done deploying the application on app service. But there are a couple of steps remaining before you actually go and browse to the application. So first is To migrate the databases, this is the first time we are running the application, right? And we need to have the tables and the schema set up in the MySQL server. So now what we will do is we will do an SSH from the app service itself, because they're all isolated in a VNet and you can't essentially connect to the database from elsewhere. So we will do an SSH from the app service itself. You could essentially actually just go to web SSH host from the app service control site. It'll take a couple of minutes to load this, but once we have this, let's navigate to the www root folder first, and then let's run the PHP artisan migrate to migrate all the databases and create the schema. So you can see all these tables that are being created. Now the application will be essentially using these tables underneath. So one more change required before we browse to the application. Laravel application lifecycle begins in the public directory, and the default 8.0 container for app service uses Nginx, which starts in the root directory. So what we need to do is go to the configuration section and navigate to the general settings there, and put a startup command such that the Nginx configuration file in the 8.0 container, right, is changed. And the sample repository actually has a custom configuration file, so we're just going to replace the two, and that's what this command is going to be, just copying the configuration file in place of the Nginx configuration file, right? Let's click on save. And that's it. Now we can finally browse to the application and test it out. So go to the overview section, and the URL is actually populated in the overview itself. So click on the URL and the application will be loaded here, right here for you. So you can just create tasks, maybe something like complete the tutorial, right, and add a task. You can add multiple tasks here. Try flexible server for free, I guess. We'll add these tasks, and you can also delete tasks. Just run the application and get your hands dirty here. So this brings us to the end of the tutorial, but before we conclude, I wanted to recap and summarize all of these. Actually, one more point. If you want to make changes to any of these files, right, just go to the Visual Studio Code and edit any of these files, the application files or CSS, whatever you want to edit, and then go to source control here. And then all you need to do is click on stage, basically add them and commit them, and just click on the checkbox. That way, a new pipeline, because of GitHub Actions, what happens is there is another action that is put up here, and the application will be built and deployed once again. So that way, all you have to do is go to the application and refresh the application, and you will see the changes made right here. Once the tutorial is completed, I would say go back to your resource group, and you can delete the resource group altogether. Or if you want to manage your server like the MySQL server and you want to monitor it, you want to scale it up and down, you can do that as well. Like go to compute and storage and move across the queues, move to the business queue, critical queue, or burstable queue even, or add high availability or backups and so on. You can do that meanwhile while monitoring your application side by side. Now, like I said, make sure that you delete all your tutorial resource groups, because this does add to a little bit of cost for you to set up an app, DB, and a lot of VNet resources. So let's do a summary of all the steps we've done so far. The first step, we began with creating a web app plus database. With that web app plus database experience, you saw how simple it is. Just a couple of clicks and a web app and a database were spun up together in a VNet for you. Second one is review and edit connectivity. Now, typically, Web App Plus database is already connected for you, and connection strings are also automatically put together. But in cases like Laravel, in special cases like this, you might need to edit the connection information and add them. So typically 1 and 2, these two steps are created by the Web App Plus database experience itself. Now the third step is to deploy your code using GitHub Actions or other sources like local Git, or you can use Azure pipelines and so on. Now the sample code here, we used GitHub Actions and you saw how simplified and integrate the experience is. If you make any changes to your code, if you use tools and services like GitHub Actions or Azure pipelines, the CI/CD pipeline is already managed for you. So you don't have to worry too much about pushing the code again to the app service and going through the whole life cycle. Now once the code is deployed, the next step is to generate database schema. Especially this makes sense when you are developing and deploying the application for the first time. You need to make sure that your database schema, the tables, everything are already set in place. Now, if you already have a database and you're just building a new application on top of it to use that, then this step may not be required. Or if your application is being run for the second or the third time, you don't really need to generate the database schema again. And the final step is to run and test the application. If there is any issues, then you modify the sample code, and then GitHub Actions will take care of making sure that that application code change is also deployed into production, and then you can run and test. So this goes on in a loop. So that brings us to the end of the tutorial and its summary. This tutorial is documented in our Microsoft Docs. We'll share the link to you towards the end of the session. But I hope you try this out, test this out, and let us know how this works. If you have any questions, do feel free to put it on the chat window right away, and I can help you and address them towards the end of the session. Now, apart from this Web App Plus DB experience, I wanted to cover a couple of other scenarios as well. First, now in this Web App Plus DB, both the web app and the MySQL database were put in one single VNet. What if in your environment you have two different VNets, one for your app and one for MySQL? So what do we do then, right? Let's try this out through a demo. Let's create an Azure database for MySQL Flexible Server using private access in a different VNet altogether. So let's go through the entire creation process for MySQL Flexible Server. Give a resource group, give a server name for the server. Here, let's do MySQL DPS VNet demo and choose a region, and let's keep it a development server for now. Give the admin username and password as we did earlier as well. Then let's go to the networking tab, and here choose private access. You also have the flexibility to create a virtual network from within this blade itself. So let's create a new virtual network, change the name and the address range, and also create a subnet. Now this subnet should be, of course, part of the VNet, right? Provide the same address, required address range for it. And this subnet actually, just click on OK for now. This subnet is actually going to be delegated for MySQL Flexible Servers only. You cannot have any other servers in that subnet except other MySQL Flexible Servers. And we'll create a new private DNS as well. I'll explain why this is required later on. So let's go ahead and review plus create. Just quickly review that we are going to create a new VNet, a new subnet, and a new private DNS zone. So this is how you essentially create a Azure database for MySQL Flexible Server using private access. It's going to take a couple of minutes to finish deployment, and once the deployment is completed, let's go have a look at the server. Here you go. Let's actually have a look at the resource group itself. You can see that there's a VNet created, there is a private DNS zone created for you, and there is a MySQL server as well. Now, back in the application, let's use the Laravel application that we created earlier. What we'll do is we'll change the configuration of this Laravel app to connect to the server that we just created. So just go to db host, password, username, and I guess, yeah, database name is something that we have to edit. So let's do that quickly. Let's change the database host name to MySQL DPS VNet demo, and change the username and password as well. I think my username was demo user, and the password, we'll just quickly change the password as well. Now, the SSL value remains the same, but the DB database, we have to actually create a database in our new server as well, right? We missed that. So let's go ahead and add a database. Let's create a simple, maybe a sample DB database, and click on save. Let's change the DB database value as well to sample DB. And we should be good to go. Let's click on save. Yeah, the app key, app debug will remain the same. And we have changed almost everything else. So let's go ahead and save the settings. Now that we have established that connection, how does this VNet communicate with the VNet that houses the MySQL database, right? That is this VNet DPS VNet demo. For that, the first thing we need to do is establish a VNet peering. So pair this VNet to the other VNet. Select any of this. Either you go to this VNet or the app VNet, just click on it. Either one is okay. Let's just go to the MySQL VNet itself and go to peering and create add. Let's create a peering link name. Here let's do this VNet MySQL, and the other VNet will be VNet app because it houses the app. If you know the resource ID, go ahead and give it. You can extract it and give it, but let's just use the GUI here. In our subscription, let's just search for the other VNet. And yeah, that's correct, right? And let's go ahead and click on add. So once this is added and the peering status is connected, we are good with the VNet peering piece. Now the next step that we have to do is go to the private DNS zone and create a virtual network link to the app VNet, because the app service in the VNet, which is peer to this, cannot actually resolve the MySQL DPS VNet demo name unless you do this. So let's go click on add. Let's create a link name, maybe MySQL app link, and again, if you know the ID, great. Otherwise, let's just use the GUI and pick the VNet. I think the VNet was, yeah, Laravel VNet. And click on enable auto registration before you click on OK. So once you have done this, let's wait for the link to be created and the link status to be complete. So let's give it some time, and once the link is completed, let's go to the Laravel app and let's go ahead and SSH, because one step that we haven't done is we created a new database, right? We need to migrate the databases and the tables onto this database. So we have to redo that step. Let's do the PHP artisan migrate. And once that is done, we can go ahead and navigate to the application itself. So click on the URL and the application is loaded for you. You can go ahead and test out your application just as you did before. So that is one scenario that I wanted to cover. Now, the other scenario that I wanted to show you is so far we have been using private access connectivity that is safer and the right method to connect your app in MySQL. But I also want to show you how it looks when you're using public access connectivity. And I would recommend you do this only for your test or dev workloads, but I wanted to show a quick demo of that as well. So in this case, we will create an app service and a MySQL flexible server with public access, connect them, and we'll use local Git to deploy the application. So again, step one, creating an Azure database for MySQL flexible server. This time we are going to use public access connectivity. So let's go ahead and click on create. The first few steps remain the same as what you saw earlier. Select a resource group. I think I've created another resource group for this. So put in your server name and yeah, that's about it. Choose the region that's closest to you. Put in your admin username, password. Again, the steps remain the same so far. But in the networking tab, you will choose public access. And because an app service is going to connect to this, let's choose allow public access from any Azure service. Not recommended always, it's not as secure, but for dev test, this is the best way you can create a app quickly and test it out, right? So let's click on create. And once this deployment is completed, again, it's going to take a couple of minutes. Once this deployment is completed, we will create an app, a web app itself. So for that, we need to create an app service plan first, which will define the set of compute resources that are required for the application. So let's choose a resource group. Let's choose the same resource group that I used for the MySQL server. Create a plan name. And you can choose the region in which this is hosted. You can then choose the pricing tier. For this demo, I'm just going to choose a basic tier. You can use a free tier as well just to try things out, or use production tiers for your application. Then that's it. Just review and create it. Click on create. And once this deployment is completed, that's when you will create a web app. Now, you don't really need to do this one by one. While creating a web app, you actually do get an feature and flexibility to create a app plan from within that. But I just wanted to go sequentially so that you understand the process. Now, let's go to the resource and create a web app as well. So to create a web app, not much details required again, just the resource group name, the web app name, choose a runtime stack. Let's choose PHP 8.0 again. My app is a PHP app this time as well. Then let's choose the plan that we created earlier. Again, if you hadn't created one, you can actually create a new one right here. So let's go ahead and look at yeah, deployment, networking, monitoring. I think we can skip these for now because we'll be using local Git, not GitHub Actions this time. So let's go ahead and review plus create directly. So you have an app service app being created in the app service plan that you have mentioned. Now let's go to the resource, and first let's actually configure the deployment in the deployment center. Let's choose the source as local Git for this time. And you'll need one other set of credentials, that is the local Git credentials, to be able to push the application onto the app service. So create a username and password that you can remember and click on save. Now this password and username will be asked for when you are pushing the application. I'll show you how that will work as well. Now, the second thing that you need to do once the deployment is set up is configuration to connect your application and your database. Again, like we learned last time, let's create new application settings, a database host. Yeah, before that, we need to create a database itself, right? To be able to connect from the application. So again, let's create a sample DB database and let's add database name, database host name, password, um, password and username, and a deployment branch which needs to be main, and MySQL SSL which is showing true. Once that is done, let's go ahead and deploy the application itself using the Cloud Shell. Now, the application that we're going to deploy is in the Azure Samples PHP MySQL app service. You can navigate it and have a look at it. We will just clone this application first onto our local. Here I'm going to use the Cloud Shell, but you can also do this from your terminal. So let's go ahead and clone it. And then navigate to that folder. Then we will set the branch to main and let's copy the clone URL. So basically this is the remote for the app service, and let's copy this and push our current application onto this remote. So first let's add this as a remote. We'll name that as Azure, and then let's just do a git push. And that's about it. Once you do a git push, the application it's going to ask you for the password, the credentials that we mentioned earlier, right? So input the password and that's it. The application is going to be pushed onto app service, and once the deployment is successful, you can just navigate to the app itself and play around with the application. This was a simple product catalog application that I whipped up. Not as pretty as you can expect it to be, but let's just try this out, right? Input a product name, some price, click on submit. Yeah, you can view catalog, you can play around with the application, and just for the sake of testing it out. So that ends the second scenario as well that I wanted to talk to you about. This entire exercise is actually present in this Learn module, Develop Apps with Azure Database for MySQL. And you have an exercise here with a sandbox, and you can try this entirely for free. You don't need to have a subscription or anything, and you just need to go to this link and click on Activate Sandbox and follow each of these steps. Most of the steps are in CLI, just a copy and paste, and the Cloud Shell is also available for you on the right. So just do try this out. You don't need to install anything or worry about anything to try this out as well. So that's it. That ends the second scenario. Now, one more thing that I want to talk to you about before we move to the application best practices section is Azure Service Connector. If you have to connect an application with a database, what you've been doing so far is either using connection strings or using application settings, right? Now, Azure Service Connector is something that's newly been launched a couple of months ago during build, in fact, which connects any of your compute services with Azure Database Services such that it actually validates the connection even before you set it up. And even after you set up the connection, it will give you a way to check the connection and understand the status of the connection at any point in time. Let me directly go ahead and show you how this works. So let's go to a simple application and just scroll down to the service connector section. So to create a connection, all you have to do is click on create connection. Search for a service type. You can connect to any of the services like Flexible Server, Cosmos DB, SQL, Postgres, anything that you are wanting to connect with. Let's select MySQL Flexible Server for now. Select a connection name. Choose a MySQL Flexible Server for this. I think I've created a special server just for this demo. So I'm going to go and connect to that. And choose a MySQL database that you want to connect to. Choose the client type of the app service. Search for the authentication here, put the username and password for the service, and then click on networking and click on review plus create. So it actually runs a validation right here, and when you click on create, what it will look like is this. the Azure Service Connector automatically creates all these app settings for you, and you also get a chance to validate the connection at any point in time to make sure that the connection between the app and the database is perfect. So this is the power of Azure Service Connector, and I'd really urge you to try this out and use this instead of Azure application settings, so that first of all you make sure that all the values that you're entered is correct, and then you also get an opportunity to check and validate the connection at any point in time. So moving to the last part of this section, that is best practices for application development. I'm going to cover a few best practices that's top of my mind, and I'm also going to cover a few extra best practices that you can follow if you want to make sure that your application is highly available and reliable. All right. So we have an application, we have an Azure database for MySQL Flexible Server. First thing, make sure that you have co-located these resources. This way, your application performance is increased heavily. The latency is removed when application is talking to database. Second, right size your application as well as your database. There are a lot of SKUs in the app service plan as well as in the MySQL flexible server. For example, in MySQL flexible server, you've got a burstable SKU for development, you've got a general purpose SKU for a balanced production database, and then you've also got business critical, which is for high performance servers. And same with app service plan, you've got basic plan, premium plan, and so on that you can use and right size your application. And even after you finish the right sizing, after your application and database is set up, the next thing that you should do is continue to monitor your application and database for performance and scale up and down if you feel like the CPU, storage, compute, or storage, right? If any of these is lacking, make sure that you scale up or down accordingly. The next is in terms of security. Ensure network isolation. Like you saw in the Web App Plus database secured in a VNet, right? That is one of the best things that you can do. Use private access or private links and secure them in a VNet. And then SSL connectivity. SSL connection is actually enabled by default for Azure Database for MySQL Flexible Server, and we would urge you to continue using that. Next is retry on transient faults. In the cloud world, there's always going to be a few network issues or glitches, right? And you don't want your entire application to fail just because of that one small glitch. That's why your retry logic has to be strong, so that if the connection fails once, you try after a couple of seconds and make sure that your application is still continuing to connect to the database. Another interesting thing that I would recommend is implementing connection pooling using a connection pooler like ProxySQL. MySQL, any MySQL database or a server has a maximum limit, a maximum connections limit that is allowed. Now you don't want to hit that. If your application and you have a lot of users and there are a lot of requests coming to MySQL and you hit that, your performance will be degraded heavily. So use a connection pooler, which will actually reuse few of these connections and make the performance much better. The next is automate CI/CD tasks, that is use DevOps, not just for your application, but also for your database. Application you saw just now, right? Using GitHub Actions. The same you can use for managing database schema updates as well. GitHub Actions as well as Azure Pipelines are compatible and supporting database schema updates to Azure Database for MySQL Flexible Server. Now, the last few things that I wanted to cover are for a high performant and highly available application, especially if you are in an enterprise organization. High availability. MySQL Flexible Server has a lot of high availability options for both zone redundant as well as same zone, that is within the same availability zone. Then you've got geo-redundant backup, which will help you protect against region failures. And then do implement caching using maybe Redis cache to make sure that the performance is increased heavily. Now, the last one is read replicas. We have this functionality called replication in MySQL. And in MySQL Flexible Server, what you can do is create several other read replicas. And when your application is heavily read intensive, you can send all those read requests to these replicas, and your primary server can continue to do the write operations. And this way, you can actually improve your performance heavily. So these are a couple of the best practices I wanted to share today. There are a lot more, and there's actually another session that we are doing in DPS which talks about how to implement a fault tolerant application with MySQL Flexible Server. So do go ahead and watch that for more best practices. So here are a list of resources that you can use to learn more about MySQL. We've got our homepage, our documentation and blog site, and we've got a couple of video tutorials as well. Beginner series, which focuses mostly on what is Azure Database for MySQL and all the features and core concepts. And we've got Developer Essentials video series, which focuses more on the developer side of the world, how to develop applications with app service, Kubernetes, and so on. And for all of this, you have a free trial available with Azure Free account. It's up to 12 months free trial that is available. So go ahead and navigate to ak.ms, try MySQL free, and get started right away. And stay tuned for updates and announcements on our social media, or write to us if you have any questions. And lastly, I just wanted to share all the other MySQL sessions we have in DPS 2022. We have an introduction to MySQL session as well, which goes a little deep into what is MySQL, and then a little more advanced sessions on improving performance, how to work with Azure Data Factory, or like I mentioned earlier, building fault-tolerant applications and so on. And that brings us to the end of this session. Thank you so much for listening in. I'm going to be available in the chat window for the next couple of minutes. So feel free to drop your questions or queries on the chat window and I will address them directly. Thank you so much and hope you have a nice day ahead.